This is video homework for Tim Barron, Physics 229, Strength and Elasticity of Materials, problem 4.5-26. What we've got here is a cantilever beam as shown in the figure that is supporting a concentrated load and a uniform load, and they want us to draw the shear force and bending moment diagrams for the cantilever beam. So what we're going to do to solve for this problem is we're going to solve for the reaction forces and MA for the entire beam using equilibrium. Then we're going to break it into sections AS, ST, and TB, and for each section we'll use equilibrium to solve for the shear force and bending moment, and then we'll determine Vmax and Mmax by choosing the highest magnitude value. And finally, we're going to create a diagram using bendingmomentdiagram.com. First, we'll solve for the full beam using equilibrium. We'll get AY is 4.6 and MA is 6.24. Then we'll solve for section AS, and at x equals 0, we've got VA equals 4.6, MA equals minus 6.24. At x equals 0.8, we've got VS equals 4.6, MS equals minus 2.56. At ST, we again use equilibrium, and we end up at x at 0.8 is VS equals 1.6, MS equals minus 2.56. At x equals 1.6, we end up with VT equals 1.6 and MT equals minus 1.28. And finally, we solve for section BT, and we see at x equals 1.6, we've got VT equals 1.6 and MT equals minus 1.28. After all the calculations, we see that Vmax is equal to 4.6 and Mmax is equal to 6.24. The bending moment diagram from bendingmomentdiagram.com confirms Vmax at 4.6 and Mmax at 6.24. In conclusion, to solve this problem we used equilibrium. First we solved for the entire beam, then we broke it into sections and solved for the sections, and we found Vmax and Mmax. Then we used bending moment diagram to create the diagram, and we verified our answers. Assuming the beam is steel, we can see once again how strong steel is, with Vmax at 4,600 newtons being about 1,033 pounds. That's 4 football players on a 5-foot bar.